grade. Congratulations for making it to Chapter 2. In Chapter 2, our objectives for our first lesson, which is writing equations, is going to be to translate sentences into equations and to translate equations into mathematical sentences. Our standard for today is Algebra CED Standard Number 1. Let's go ahead and start our vocab. For vocab in Lesson 2, all we got is one definition, formula. It's an equation that states a rule for a relationship between certain quantities. So what that is like the formula for like the area of a square could be side times side, rectangle, length times width. These are stating a rule that any shape on those will always equal length times width or side times side. We have many different formulas in mathematics. We're going to be looking at some today, and we're going to be solving by using those formulas. So let's go ahead and start example 1. In our first example, what we're going to be doing is we're going to be translating sentences into actual equations. So we're going to read the sentence here, and we're going to translate it into an equation. So it says, translate this sentence into an equation. A number b divided by 3 is equal to 6 less than c. So we're actually going to write this out as an equation. The difference between an equation and an expression is an equation has an equal sign. An expression does not. So first thing we want to do is we want to write what they said. A number b, so I'm going to write the number b, divided by 3. So I'm going to write that b is being divided by 3. So I'm going to write it kind of like a fraction because I know that division could also be this bar right here. B divided by 3 is equal to, so I'm going to draw an equal sign because that's what the word is equal to means. 6 less than c. So I have 6, the word less than means take away c. So 6 less than c. If I had 4 less than 10, I would take 10 and minus 4. Well, it says I'm taking 6 less than c. So what I should do is I should start with c and take away 6. This is the equation, or the mathematical sentence, that we got from what we read. Remember that if you see the word less than or more than, typically means that you're going to subtract or add at the end of the problem. If I have 6 less than c, that's like taking 6 less than 10. Well, if I had 6 less than 10, that's 4. So I really took 10 minus 6. So in this case, it's c minus 6. Let's go ahead and do another problem. In this example, we're doing kind of the same thing. We're still translating into an equation. It says translate the sentence into an equation. So here is our equation that we're actually going to translate into numbers. Right now, it's written as words. So if you're thinking about this, this is actually kind of like what we did in Chapter 1, Lesson 1. But now instead of being expressions, we're now doing equations. Equations need to have equal signs. 15 more than z times 6 is y times 2 minus 11. So what we do is we're going to kind of think about it breaking up into small pieces. 15 more than z. So what we're going to do is we know we're adding 15, because that's what the word more than means, then z times 6, so I'm going to have 6z, because that shows that I have z times 6. The word is in mathematics actually means equals y times 2, so I'm going to have 2y, because remember the numbers always go in front of variables, minus 11. So I'm going to have a minus sign, and it's 11. So this problem should kind of be stating some of the things that I'm reading up here in the correct sequence. 15 more than z. Since it says more than, I know that that's going to actually happen kind of at the end. So what I'm going to do is I'm going to write z plus 15, but I know it's z times 6. So it's really 6z plus 15. The word is means equals y times 2, so that's 2y minus 11. So 6z plus 15 would be the correct answer, or you could have wrote it as 15 plus 6z equals 2y minus 11. I would accept this too, just because of the fact that addition is commutative, and commutative means the order in which you add does not matter. So both of these would be correct. So if you wrote it this way, you're okay. If you wrote it that way, you're okay as well. These are the only two ways, though, that you could write this problem based on what we're reading. Let's go ahead and keep moving. In example 3, still translating sentences into equations. So we're going to take this sentence and write it using numbers. A number C multiplied by 6 is equal to 2 more than D. So what I like to do to make sure I get it right, if you can't tell, is I like to actually write the information above the sentence. So that way I know kind of an idea of how I'm going to write my numbers in. So number C, and it's going to be multiplied by 6. Well, when we multiply by 6, we get 6C is equal to, so that means I'm going to have an equal sign, 2 more than D. So I could write it as D plus 2, or I could write it as 2 plus D because, again, that's commutative. Reminder, though, that the word more than or less than means it typically happens at the end of the problem. So in this case, I'm going to say that my answer probably would be 6C equals D plus 2. Now, the other answer you could have is 6C, because it's 6 times C equals 2 plus D. And again, that's because addition is commutative. Commutative means the order in which we add numbers does not change the answer. So either one of these answers would work for this problem. In example 4, still translating, says 3 less than a number A divided by 4 is 7 more than 3 times B. So start by changing everything to the numbers and kind of writing the signs in between that we might have, and then we're going to write the problem out after we're done kind of manipulating the sentence to kind of get an idea of what's happening. So I have 3. I know the word less than means take away something. A number A, so I have A divided by 4. I know I'm going to have divided by 4 is 7 more, so I'm going to have 7 and more than 3 times B, 3 times B. So even if I just wrote kind of ideally what they say here in the exact same order, it's not 100% correct because, again, we need to think about what they're saying. 3 less than a number. The word less than, again, means it happens at the end of the problem. So I'm going to take 3 less than a number being divided by 4, and they tell me that the number is A divided by 4. So first thing I'm going to say is I have A divided by 4, and I'm going to take 3 away, because that's 3 less than A divided by 4. Is, the word is, I totally forgot, the word is means equals. So equals 7 more than 3 times B. So you could write 3B, because that's what 3 times B is, plus 7, because again, the word more than means we happen at the end. But if you were to write it again this way, A divided by 4 minus 3 equals, the other way would be 7 plus 3B. Again, that's okay. Whenever it talks about more than, the order in which we add numbers, again, does not matter because that's commutative. And adding, we can move numbers around as long as they're both adding. There you go for that. Let's move on to some formulas. We can still translate sentences into equations, even looking at actual formulas that we have in mathematics. So here's a formula about geometry. It says the perimeter of a square equals 4 times the length of a side. And that's because if I had a square, if I could draw a good square, if I had a square, we know that the perimeter is when we take all of the sides and we add them together. So side, 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 side. When we add all 4 sides together, we'll get the perimeter. Well, here it says that we can actually create an equation or a formula, because it's a mathematical rule, that anytime we have a square, we can just use this formula and get the answer instantly. The perimeter of a square equals 4 times the length of a side. So we're going to use P for perimeter equals 4 times the length of a side, 4 times whatever the side length is. So in this case, our perimeter is equal to 4S, because S stands for the side length. And that is how we take information that's given to us and write it in a mathematical sentence that creates a formula that is a mathematical rule based on something that we do know. So this is one of the laws of mathematics. Perimeter of a square, 4 times the length of a side. For example 6, what we're going to be doing is translating sentences into equations still, and we're still looking at actual formulas. So here we have another geometry formula. Maybe this is one that you might have heard about, but that's okay. The area of a circle equals the product of pi and the square of the radius. So the area of a circle equals the product of pi and the square of the radius r. So they're kind of telling us some information again, kind of like what we were doing. What we could do is we could write down kind of what's happening. A reminder that the word product means the answer of multiplication. So the area of a square equals the answer of multiplication of pi and the square of the radius. So we're going to have multiplication between pi and the square of the radius. Well, that means r squared. So the area of a circle equals, and for area, since they didn't give me a variable, I think a is going to be a good variable for that. So what that means is that the area of a square equals pi times your radius squared. Now, just to kind of remind you, here's a circle right there. Area is the space that if I were to fill that circle in, that's area. So the area of any circle, all you got to do is take pi times its radius. Radius is half of the diameter from the center to the outside. And then you square that, and that'll tell you how much space is occupied inside of your circle. So moving on. So in this problem, we have to translate into sentences what we see. So it says translate the equation into a verbal sentence. A verbal sentence means how you would say it. So what you're going to do is you're actually going to write words for how you would say the sentence. Kind of like what we did, again, in Chapter 1. So the first thing I see is 12. So I'm going to write 12 minus... Now again, anytime you write a sentence, you need to include every operation that's happening. So what is 2 doing to x? Well, that's multiplying. So 12 minus 2 times x is equal to, and then negative 5. So in this problem, I was able to look at this problem and I was writing exactly what I saw. I saw 12 minus 2 times x is equal to negative 5. The equal sign tells me that they're equal. Everything else is what I see, and we're good to go. You can also use the word is for the equal sign instead of saying is equal to. You could just say 12 minus 2 times x is negative 5. Let's go ahead and keep moving on to some more problems of these. So in this problem, I have a division problem happening that has a fraction, minus equals negative 1. So again, we're still going to translate it into words, how we would say this phrase. So first thing I see is 12 again. So I have 12. Well, this line right here means divided by. So I have 12 divided by b minus 4 is negative 1. So this problem right here, I have 12 divided by b, that's the first thing I see, minus 4 is negative 1. And that's all we got to do for this type of problem. So let's practice a few more, and then we'll move on to the last part of the lesson. Alright, so in this one, I have 5 with a equals b to the second power plus 1. So again, I'm going to write that kind of in words. Remember, any operation I see, I have to actually physically write down that operation in the problem. So, I have 5, and it's timesing a is equal to b squared, or b to the second power, plus 1. So in this problem, I have 5 times a is equal to b to the second power plus 1. Ideally, if you write your sentence correct, somebody should be able to read this sentence and write the exact same problem in the exact same way that you see it. So you want to try to make sure that whatever you write here matches what you have up in your original problem. You guys are doing great on this. I'm going to go ahead and move on to the last part of the lesson. Okay. In our next examples, what we're going to be doing is we're going to be writing a problem. That's why it's titled, Write a Problem. We're going to be given some information, and our job is to come up with a story problem that somebody might have to solve with the given information that we have. So we know that F is the cost of fries, F plus $1.50, or fries plus $1.50 is the cost of a burger. We also see this equation here. If we had 4 times this,
minus the cost of fries, we're going to get $8.50. So what I'm going to do is I'm going to combine all that up into one problem.
So, I would maybe say that fries plus $1.50 is the cost of a burger. And so now I'm going to kind of write a verbal statement for this. 4 times the cost of a burger minus fries equals $8 and 50 cents. What is the cost of fries?
So what I wrote here was I said, I know that if I take fries and I add $1.50, it's the cost of a burger. Cost of a burger, fries plus $1.50. Well, the story problem here tells us that 4 times the cost of a burger, 4 times the cost of one burger, minus fries is $8.50. The question is, what's the cost of fries? We know the cost of a burger, but we don't know the cost of fries. And F is our variable. In mathematics, we want to find a way to create a story problem, so we're solving our variable. So, this is how we would set up a problem. We wrote a problem with the information given, and we're trying to say, we need to find the solution to the variable that's given. That's what we're going to be doing. Let's do one more and call it a day. So our last problem for this, we're writing a problem again. So we're given some information. We have to write a story problem for the information that's given. It says h is Diana's height in inches. So h is my variable. H minus 3 is Olivia's height in inches. So again, h is my variable. And if I take 3 times h, which we know that's Diana's height, multiply it by Olivia's height, because that's h minus 3, I get 8,262 inches. So our job is to figure out what h is. So what we're going to do is we're going to write a problem that tells the reader that their job is to solve for the variable h with all the information given. So I'm going to say that Olivia is 3 inches shorter than Ziana. Ziana is h inches tall. So I know how tall Ziana is, and I know that Olivia is 3 inches shorter. Well, if I take 3 times Ziana's height, because this says 3 times Ziana's height, so I'm going to write 3 times Ziana's height times Olivia's height equals 8,262 inches. How tall is Ziana and Olivia? So in this problem, what I did was I asked the reader, how tall is Ziana? But I also want to know, how tall is Olivia? Because if we know Ziana's height, all we got to do, take away 3 more, And now we got Olivia's height. So I used the information given to actually write the story problem. Olivia's 3 inches shorter than Ziana. When we know h is Ziana's height. So if Olivia's 3 inches shorter, Olivia's height in inches is h minus 3. Ziana is 8 inches tall, so I'm telling the reader what unit of measurement I want them to use. I want them to use h as their unit of measurement. 3 times Ziana's height, so now I'm telling them what this is. 3 times Ziana's height times Olivia's height equals 8,262 inches. So using the fact that we know what it's equal to, we could potentially work backwards and solve this problem. So it says, how tall is Ziana? And I want to know how tall Olivia is. So what we did was we took all the information given and we wrote a problem that somebody could solve based on the information given. That's what you're doing at the very end of this lesson. That's it for today. You guys did awesome. Make sure you like this video, smash that notification bell, and subscribe if you haven't subscribed yet. And I will see you tomorrow.